Okay, let's take a look at the next problem here. They're asking us to find IO and VR here. Okay, and our R is going to be equal to 25 ohms. Okay, so uh, looking at this is kind of a big problem. We notice that we've got 12 volts, 6 volts, two sources, and a lot of resistors in between. So we could go the route of doing 1, 2, 3 mesh loops, but that will create a system of 3x3s, and I just don't want to do that right now. So what we're going to do instead is we're going to name these points V1 and V2, and what we're going to do is two separate nodal analysis. So I'll assume I've got a current that way, that way, that way, that way, and then that way. And I'll drop a ground down here. And we'll have 0, 0, 0, 0, 0, 0, 0. Up here, we'll have 12 volts, and then right there, we'll have 6 volts. Okay, and if we go and do it for V of 1, we'll have, I'll call that I1, call this one I2. That'll be I2, that'll be I3, and this will be I4. So if we go to I of 1 plus I0 plus I2 is equal to 0. I of 1 will be V of 1 minus 12 over 50 ohms. I of O will be V of 1 minus 0 over 100. And then I of 2 will be V of 1 minus V of 2 over 25, and that'll equal 0. Then all we'll do is come here, multiply by common factor, common denominator. So this will be 2 V of 1 minus 12 plus V of 1 minus 0 plus 4 V of 1 minus V of 2 is equal to 0. And we will get 2 V of 1 minus 24 plus V of 1 plus 4 V of 1 minus 4 V of 2 is equal to 0. And if we go and combine like terms, we'll get 7V1 minus 4V of 2, and that'll be equal to 24. This will be our first equation. If we come over here and do V of 2, we'll have I of 2 plus I of 3 plus I of 4 is equal to 0, where I of 2 here is going to be V of 2 minus V of 1 over 25. I of 3 will be V of 2 minus 0 over 200. Then I of 4 will be V of 2 minus 6 over 50. That'll be equal to 0. And just like before, we'll multiply by a common denominator. This will give us 8 V of 2 minus V of 1 plus V of 2 minus 0 plus 4 V of 2 minus 6 is equal to 0. We'll get 8V2 minus 8V1. We'll do plus V of 2 plus 4V of 2 minus 24, and that'll be equal to 0. Combine like terms, we get negative 8V1, and that'll be 13V of 2, and that'll be equal to 24 as well. All right, so all we need to do here is solve for V of 1 and V of 2. And when we find V of 1, we'll be able to calculate the current going down, and when we find V of 2, we can find the voltage across that way by taking the voltage difference. Okay, so if we go do V of 1, that'll be equal to, I'm going to use Cramer's rule here. You can either use plug and chug or Cramer's rule. It's up to you. I'll use Cramer's rule. And I'll write the matrices up here. So this would be 7, -4, -8, 13, V of 1, this would be V of 2, and that'll be equal to 24, and then 24. Okay. This column's V of 1, this column's V of 2. All right. So going through, solving for V of 1, 24, 24, -4, 13, over determinant of 7, -8, -4, 13. So this would be 24 times 13 minus -4 times 24 over 7 times 13 minus -4, -8. And let me grab those numbers real quick. Okay, looks like 408 for the top and 59 in the denominator. So therefore, V of 1 will be equal to 6.915 volts. Okay, and then if we want to do V of 2 in the same fashion, determinant of 7, -8, 24, 24 over determinant of 7, -8, -4, and then 13. 7, 24 minus 24 times -8 over 7 times 13 minus -4, -8. We already found the denominator. And if we go into the top here, let me grab this number. There we go. Okay. Yeah. 360 over 59. Therefore, V of 2 will be equal to 6.101 volts. Okay. So now if we go and take the voltage difference, so V, what do they call it? R. So V of R is equal to V of 1 minus V of 2. So therefore, V of R is going to be equal to 6.915 minus 6.101, 0.814 volts. Okay, And then now if we go and do I of O, just going down, will just be V of 1 divided by 100. So therefore, I of O is going to be equal to 0.0691 amps. All right, and that'll do it for this problem.